Bouncy, 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 bounce. Bouncy, 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 bounce.
Man, I sure am tired of being stupid. Man, I hate how I'm 11. And if I look back from my education, I can really tell the reason why I'm an 11-year-old homeless boy living in a shopping cart is I have not had a foundation in quantum mechanics. If only some nice man would just, tell me about like quantum theory, electromagnetism, radiation, things of that sort, you know what I'm saying? Oh jeez. Well, would you look at that?
Sonny boy, I bet you're wondering what that fine book I bestowed upon you is. It's Quantum Mechanics, my dear boy.
Ah.
That's right, Quantum Mechanics. Big Al's Quantum Mechanic book. Book of everything. I was homeless living in a shopping cart once. I had a crippling addiction to, lack of a foundation of quantum mechanics. I was addicted to ignorance and crack cocaine.
That's so similar to me.
Exactly. And through the power of Christ and quantum mechanics, look at me now, throwing books at 11-year-olds.
Man, I never heard something like that before. I'm ready to learn.
Oh, yeah.
We are now heading into the quantum world. Now before we do that, we should understand what quantum even means. It comes from the word quantity, meaning how much of something you have. And in this case, we have a very, very, very small quantity. And when something is quantized, it means that it's only in whole numbers. Now, first let's talk about electromagnetic radiation. You've probably heard about radiation in reference to X-rays or uranium, but there are many different kinds of radiation, including the light we see every day. These all have one thing in common. They're waves. These are basically like waves in the ocean, but just made of energy. There are three important properties of waves: wavelength, amplitude, and frequency. These are very simple. Wavelength is just how it sounds. It's the length from the beginning to the end of the wave, while amplitude is the distance from the top to the bottom, and frequency is just how many waves there are. Now, you must remember that all waves of energy always move at the same speed, and because the speed is always the same, the frequency and wavelength vary inversely. This means that when the frequency goes up, the wavelength goes down, and if you want to know how much energy a wave has, you just have to multiply how many waves there are by a number called Planck's constant, which was invented by Max Planck. Now we know that light is made of waves, but did you know that electrons can act like waves too? And that they can absorb the wave energy from light? For example, if you shine light at some metals, the electrons will become too energetic and will fly out from the atom. This is called the photoelectric effect. The atoms these electrons lie in have many properties as well. Atoms can jump from high energy levels to low energy levels, and when they do so, they leave a trail of light. Scientists use tools that pick up those trails of light and put them on a picture. Each atom has a different trail of light, sort of like an atom's fingerprint. This is called the emission spectrum, because it shows the light that the atom emits. We use this to identify atoms. When the emission spectrum is showed on a picture, it looks like this. The lines represent emitted light. Something similar to this is the absorption spectrum, which shows the light absorbed by an atom. This light is made by the rapid movement of electrons. Electrons sure are sneaky. Now, when analyzing electrons, you can only know either how fast an electron moves or where it's going. You can never know both. This was discovered by a man named Heisenberg. We call this the Heisenberg uncertainty principle, because you can only be certain about one of the two. Now that we are back to electrons, we can talk about more of their strange properties. Electrons don't actually zoom in circles around the nucleus of the atom. We discussed that we don't know exactly where electrons are at any time, and this is because of the uncertainty principle. Well, we don't know where they are, but we know a little bit about the areas where they probably are. These are called electron orbitals, and they can appear in many different shapes and sizes. They are simple, like a sphere, but some are more strange and can be shaped like a pear or a dumbbell. Lastly, we have to know how to write out the configuration of an atom. These configurations just show us the ways in which the electrons are spread out around the atom. Let's try and write the electron configuration of scandium. Scandium has 21 electrons. We would start by filling up the lowest energy level orbital, which holds 2 electrons. This one is labeled S for sphere, because that's the shape of it. We fill up the next orbital with 2 electrons again. Next, we fill up the orbital labeled P because it is shaped like a pear. It holds 6 electrons. We continue by filling another s orbital which holds 2 electrons, another p which holds 6, and d which holds 1, and then a last s orbital which brings us to a total of 21 electrons in our configuration. Now, I hope you've learned something about the quantum world today. I got a blast.
I hope you learned something about quantum mechanics today, kids. I know I sure did. I hope you thought this video was fleek, as the kids say, cause I sure learned a lot. What about you boys?
I feel like I could go get a degree. Jesus Christ, I'm enlightened.
Woohoo! Mommy like.